good morning or afternoon, depending on which group it is. We're going to try something slightly different today. I've gone and got myself the flu, or corona. We'll find out. I got a test done today. Wholly an unpleasant day. Car broke down on the way. And the test itself was a bit strange. You have to put a little cotton bud to the back of your throat, so that made me gag. You have to stick it right up your nose, and that's uncomfortable. But I had a nice chat with the people that were there. So you win some, you lose some, make some new friends, that sort of thing. Okay, so my lessons, you know by now, are difficult to put onto paper, and I don't really want to bore you with a load of random tasks to do, because my lessons aren't that way, and I'd like to keep with a similar type of theme this whole year. So whenever I'm ill or isolating, or I don't know, have to leave the country for whatever reason, I'll do a recording of my lesson from my bedroom, or from the prison in Argentina, depending on what kind of mischief I've gotten up to. So, a little bit of an update. We are going to be primarily focusing on the exam unit over the next few months. There's been a slight timetable change, not for you, but for me. So as of term 2, I will have one fewer lesson. Basically the hour slot on the Monday. So not this lesson, the next one I won't have with you. You'll have that with Faranak, I believe. But certainly for the next few months, it's business as usual. Because the timetable's been changed a little bit, I'm going to focus more on the exam unit. And I want to get the drier stuff out of the way earlier. There's a little bit of maths. It's a little tricky to get your head around, but I've complete faith that you can. And I apologise if I take a moment to just pause and think. I don't like acting in front of a camera. I prefer to be able to see people's faces and their expressions. I like it if you can call me out if I'm going on a tangent. I like to know whether you don't understand something or not. So I'll try my best to explain the concepts. If you don't understand something, write it down. Send me an email. Let me know what you didn't quite understand, and I'll try to explain it in a slightly different way. Unfortunately, I don't have the privilege of being able to know that because, well, this is a recording. Or is it live? Who knows? Oh. Okay. Let's start off and see if you've done the work from home last week. So, 10 minutes. Get some pens and paper out for me, please. And I'm going to show you a little worksheet quiz. There's about 10 questions. If you've done the work at home, it will go better for you than if you hadn't. If you haven't, then this is the opportunity to hopefully start learning it. I don't mind if you're not on track, as long as you keep up. That doesn't make any sense. That's a complete contradiction. As long as you catch up. Look, life happens. Sometimes you get the flu and the world falls out your arse, and then you get a fever of 40 degrees. You can't tell, maybe you can hear it from my voice, but I haven't had fun this weekend. Oh well. Okay, I'm gonna minimize. Oh, there I go. There's pro streaming skills, but not pro mouse skills apparently. Oh. Alright. It's not that one. Oh no, have I not got it prepared? Surely I have. Surely I have. There you go. There you go. It's been a little while. Okay. For the following hazards, hopefully the screen is big enough. I'd like you to write down what you think they are, and the potential negative effects of them. Oh, let's add one more because I'm fun like that, and have one method of mitigation or prevention. So, I'll give you an example for the easier one that even if you hadn't done the work from home, you should be able to work out yourself. The second one is flammable. So you'd write, well, I guess you don't have the sheet here, so just label them 1, 2, 3, 4, 5, 6, 7, 8, 9, that kind of thing. I will print this out for you at a later date, but certainly because this recording from home has been very last minute, it will save a lot of printing time. So, write flammable for this one. Potential negative effects, burning. Death by fire. One way of preventing it or mitigating the damage if you can't prevent it, keep away from sources of ignition. And I'm not going to give you any more because I don't want to take away from your creativity. So I'll give you about 10 minutes for that. If you could do that for me now. I'm not sure how the timing is going to work, so I guess I'd need the cover staff, whoever's covering, to help me out a little bit with this. I'm just going to be silent for about 10 minutes. Although the awkwardness is eating at me. After the 10 minutes, I'm going to go through it. If you could structure the class yourself, and when I give you the instruction, could you go around the class one by one, giving me the name of the symbol. Not quite yet. In fact, do the names of the symbols to begin with, because if you can't remember or you're not sure, it'll be good to get everyone caught up before you do the potential negative effects or one method of mitigation or prevention. Probably hide my, what's it called, bookmarks bar. Nah, it's fine. It's nothing too embarrassing. Alright, change of plan. I'm not liking the silence. So the top one is explosive. I'm going to slowly go through these. Try to think of a potential negative effect. The second one is, can you guess? Is flammable. If anyone didn't get that, I think you need to ask yourself some long, hard questions. Third one looks like a little O with a fire on it. That's an oxidizer. An oxidizer is something with lots of oxygen in it, in the compound. Oxygen is fuel for a fire. So if you put something with lots of oxygen onto a fire, it makes the fire bigger. What do you reckon could go wrong if you make a fire bigger? Well, Australia found out right at the beginning of the year. Who would have thunk that that was the feel-good story of the year? It all went downhill after Australia burnt to a crisp. The fourth one, compressed gas. Kind of looks like a bit of a cricket bat. What could go wrong with compressed gas? Fifth one, corrosive. Sixth one, toxic. Seventh one, general hazard, danger, watch out. Oh, I forgot, there's one over here, couldn't quite see it. Hoo-hoo, you thought the test was over. No, no, no. Is that the seventh one? I don't know, I lost count. 1, 2, 3, 4, 5, 6, 7, 8. The eighth one. This one tricks a lot of people. The way I like to remember it is, where is that little star located? It's located in the chest. What could be in the chest? Well, your ribs, your heart, your lungs. This is referring to your lungs. It's a respiratory hazard. Respiration is all to do with breathing. The final one. It's a little tree and a little fish. I like to remember this as death to trees and fish. It is environmental hazard. Okay. So I'm going to just list through a couple potential negatives and a method of mitigation or prevention. Hopefully you've got a few. I'm going to assume you've got a few. Top one, explosive, potential negative effect, death by explosion or shrapnel, piercing by objects that have been caught up with the explosion, structural damage to buildings, which may or may not cause the building to collapse in peculiar ways. Second one, flammable, burning, death by fire. Oh, wait, I forgot the first one. Method of mitigation or the prevention. Keep it away from fires. A lot of these will be common sense. Put it in a bomb-proof room. If it's going to explode, at least, put it in a bomb-proof room. Flammable, burning, death by fire. Keep away from the ignition. Put it out with a fire extinguisher. Ooh, let's talk about fire extinguishers. 3 primary ones. There are water, foam, and CO2. And some are not relevant or not very effective for certain types of fires. For example, an electrical fire, you don't want to put water on it, because electricity does this funny little thing to water, and it splits it into its components. Its components are hydrogen and oxygen. Both are flammable. So, What do you not want to throw on a flame? Flammable stuff. So don't put the concentrated fuel onto that fire. CO2 is a good one for that. You just douse it so there's no oxygen. I can't remember off the top of my head what foam is useful for. I think it's good for electrical fires. Because you also cover up the electricity so someone can't accidentally touch it in case they were curious after they just put out the fire. Some individuals are. It would have happened at one stage. Ooh. Put out the fire. Wonder if it's still hot. Then electrocution and death. Okay. Oxidizer. Potential negative effects. Makes fires bigger. Means more burning, more death, more danger. What can you do? Keep away from fires. Pretty much that. Compressed gas. Potential negative effects. Explosion. Fire. In case the canister decompresses quickly, that's basically an explosion. How do you prevent that? Well, keep them away from sources of fire, keep them in a special bomb-proof room, that kind of thing. Corrosion, potential negative effects, well, death by having your face melted off, or chewed through by sulfuric acid, or permanent disfigurement. It could also do structural damage. Nasty stuff, corrosive. Method of prevention, wear appropriate clothing. So, no swimwear. Make sure you got corrosive resistant lab coats. Gloves maybe. If you get it on you, wash off appropriately. We should have little hazard cards with every experiment so we know what to do if you accidentally get something corrosive on you. Next one's skull and crossbones. Toxic. Potential negative effects. Death by poisoning. Or worse. Having to live with a severely crippled body due to poisoning. What method of mitigation or prevention? Don't eat it or drink it. Nice. Exclamation mark. That's sort of a general hazard. Oh, excuse me for a moment. Need to blow this streaming nose. I'll mute myself. That might be a bit of a theme. Oh dear. Okay. Exclamation mark. General hazard. It's if none of the other hazard labels really fit what it is. This is a way of telling you, oh, there's something going on with this stuff. Please read the label. And that will give you the instruction for it. Potential negative effects. I don't know. It's specific to the compound. Respiratory hazard. Potential negative effects. Burnt lungs. Poisoned lungs. Damaged lungs. Method of mitigation. Keep your stuff in the fume cupboard, which you can see in the corner of the room behind you. Not the door, the other side. I can imagine everyone around the classroom looking around like little meerkats. Another method of mitigation, wear a gas mask, that kind of thing. Death by... No, not death by fission trees, death to fission trees. Environmental hazard. Potential negative effects. Well, it kills stuff in the environment. And often that means it can kill you. So don't dump it into a lake. Please don't dump it into a lake. Don't dump it into the sink, because the sinks go into the sewers and we want to keep the rats and alligators and crocodiles and what else could live in the sewer. We'll leave it at that, because that was a pretty dark example I was going to give. We won't put that on the recorded Yeah, potential negative effects, kill stuff in the environment. How do you prevent it? Don't put it in the environment. Dispose of it correctly. Don't put it down the sink. That kind of thing. Nice. Nice. Okay. Should I do this? Okay. Alright. Separate page. Or same page if you'd like. But this is more note taking, so it might be good to put on a separate page. I'd like you to write in a list average, mode, median, mean, standard deviation. And I'd like you to write what you think the definition of these are in a mathematical term, or give me an example with maths. I'll give you about 5 minutes. I really hope this is recording, actually. I'll be well miffed to have to do this all again. Of course, like, you can discuss and that sort of thing, but this is for your, how would I describe it? It's good to know what you don't know. And if you get reminded by someone, you think, oh yes, no, I knew that, but actually you didn't really, did you? No. So keep discussions and stuff to a minimum if possible when you're sort of trying to write the definitions, and try to keep the chatter to a level at which people who do want to concentrate in this lesson are able to concentrate in this lesson. I can't stop you talking from this about your weekend, but it would be nice if those who do want to pay attention aren't distracted. So I guess just be a little respectful. So, average. And whilst I'm, as you know, I'll give you a bit more time because I don't want to talk whilst you're trying to think. Give you another couple minutes. These are important things you do need to know for the exam. In fact, everything that I'm about to tell you next is very important that you need to know for the exam. It's something you just have to learn, unfortunately. So introduce it early, and through repetition over the next few months, you'll be fine come mid-January. So, average. Imagine you have a list of data. Let's say 2, 3, 4, 5, 6. To work out the average, you want to add them all up together and then divide by how many numbers you've got. So I can't do mental maths, so that's about 20, I think. Is it? 5, 10, yeah, about 20. Okay. And then count how many sets of data you have. 1, 2, 3, 4, 5. So you divide 20 by 5 and you end up getting the average of 4. Now you have to be very careful, because if you just put that into the calculator and the little dash is a symbol for divide, that's it like a fraction. Due to BODMAS, it'll do this bit first and then add everything together. So what you want to do is do this bit first, get your answer, which is 20, and then do the division. 20 divided by 5 equals 4. Nice. The mode. The mode is the most common number in a set of data. So, for example, if you had 2, 4, that's 3, 2, 4, 5, 2, 9, 6. The most common number there is 2, because it comes up twice. So the mode is the most common number. In this example, it's 2. The median. The median is the middle number. The middle number when the data is put in order. So, by put in order, I mean like this. So you put the 2 to the front, 4, 5, 6. You rearrange it so it's in the right order. Then you count in from the ends. There's 3 there. There's 3 there. So the middle number is 5. If you've got an even number, say like that, you count in and you find out, oh, you've got 2 middle, 4 and 5. So you take an average of the 2 in between the 2. So you do 4 plus 5, which is 9, and then you divide by 2 to find what's in between the 2, which is 4.5. Oh dear, I'll try not to do that again. Might have woken up a few people. Woke me up. That was very loud in my ears. My ears are a bit sensitive at the moment because sickness and all that. The mean. The mean, this is a bit of a trick question. The mean is the average. They are the same thing. Different words for the same thing. So count up all your data and divide afterwards by the amount of data you have. Standard deviation. This one is a little trickier. This is something you're going to have to learn, and I'm going to try to explain it to you in a bit. Standard deviation is you use a clever little mathematical equation, which I'll explain to you in a bit, and this can tell you how much your sets of data deviate or change from the mean or the average. So if you had 2, 3, 4, 3, 2, the mean would be 5, 14. That's not the nicest number to divide, so I'll make that 3. That is 15. Do 15 divided by 5 because there's 5 numbers and that makes 3. Standard deviation is a way of us knowing how much variance does that 3 have, that average that you've had. How reliable is that 3? If there was a 40 in there, and just let's just assume that the average or the mean is still 3, for example, because there's a lot of variance in these figures. It means that these figures deviate or change from the mean or the average a lot, and therefore has a high standard deviation. This might be one that, oh dear, why does it do that? This might be one that I'll have to explain again in another way. Okay. I would like you to have a look at this data set. I would like you to write this all down for me. So it's a little experiment finding out what temperature something is at different times. This is missing seconds, and this is missing degrees. I think that's how you spell it, might not be. So at 100 seconds, you take a little recording, you find it's 9 degrees, you find another recording, it's 11, another is 10, and another is 9, and another is 11.5. Bless me. See, that would be the illness. I'd like you to write down this table for me. Once you have written the table, I would like you to calculate the average or mean for all of these. I'll run you through this one. So you do 9 plus 11 plus 10. Let's make that 11. Because the 0.5s are going to make things tricky, so I'll make that one 24.0. Okay. You do 9 plus 11 plus 10 plus 9 plus 11, which is 30. You then divide by the number of data that you have. So this is 1, 2, 3, 4, 5. You do 30 divided by 5. Wait, what has gone wrong here? It's actually more than 30. See, my calculator dead generation is showing. Please use your phones if you don't have a calculator. So that's 20, 30. That's actually 50. Oh wow, I got that proper wrong. Oh well. So it's 50. Then you divide by 5 because there's 5 of them, which gives the average or the mean of 10. I would like you to do for each of the columns for me. And I'll do the same, but I'm not going to count up in my head because apparently I'm bad at that. I mean, I knew I was bad at that, but I didn't realise how bad I was. For the second one, hopefully you got about 16.4. I'm going to do these quite slowly, so hopefully you can do it before I give you confirmation. Second one, hopefully got 24.2. If the maths class consensus is it's not 24.2, it could be that I got it wrong. So don't assume that I've automatically got it right. Check with everyone. And the final one, hopefully you got 38.6. Okay. So, standard deviation is how much these values change or differ from your mean or your average. So in this case, it only changes by about 1. So you've got a pretty low standard deviation. So this value of 10 is pretty accurate. In this, it varies a bit more. It goes from 14 all the way up to 19. So the standard deviation for this would probably be a little higher than this one, because it deviates or changes more from the mean. In this one, it'll probably be a bit higher, because you've got 20 to 29, all the values all over the place. And for this one, it will deviate even more, because you've got 60, you've got 25 thrown in there, 45, all the values are all over the place, again, but to a greater degree. I would like for you, for the 100 column, to find out what the median is. The mode. Let's just do those two. I feel like dirt, or social isolation, yeah. Still here. So, to work out the median, it's the middle number. You have to put them in order. So it'll be 9, 9, 10, 11, 11. If you count in and find the middle of them, it should be 10. The mode is the most common. In this one you've got 2. 11 and 9. I'll both show up twice. So you'd have 2 modes for this. 11 and 9. Nice. Okay. Standard deviation. This one's less fun. Hopefully I can run it through with you and you're able to do it yourself. Class effort from this point on, because this is probably the hardest thing in the year to get your head around. But I reckon you can. I reckon you can first try. Okay. Let's just get the equation up for you. Where is it? Bear with me 1 second. There it is. I'd like you to write this down for me. Okay, let's... Bear with me 1 second. Sorry. There you go. I'd like you to write this equation down for me. Underneath, I'd like you to write a little legend or a key of what all those symbols mean. S stands for the standard deviation. This big hat thing, weird looking hat. The V with the line horizontally means square root. So I haven't necessarily written that, but could you write that for me? The pointy E, or Greek epsilon, means sum of, which means add them together essentially. The X without the little hat on top means one piece of data or result value. The X with the hat on top means the mean or the average. The little 2 means squared. The horizontal line means divide. The N means the sample size, so for example here we've got 5 of them. And then -1 means take away 1. I'll go through that again. The S is the standard deviation, the thing you're wanting to calculate. The weird V on the first bit of the equation means square root. The pointer E means sum of, which is adding up. Oh, I forgot to talk about the brackets. The bracket means you do this first. X without the hat means one data value. So, for example here, it will be either 9, or it could be 10, or it could be 11. It could be any of these. The X with the hat is the average or the mean, which you've calculated here. The tiny little 2 means squared. The line, horizontal line, means divide. The N means the sample size, so for this we've got 5 of them, so it'd be 5. And the -1 means -1. Okay. Let's get paint up again for me. If you need more time on any particular point, I should have said this right at the start, please ask the delightful individual who is covering for me in my moment of need to pause the video. Nice. Okay. Hopefully you can see this all. Okay. So, this might look a bit complex. It really isn't. Imagine it like a recipe for baking a cake, and these are the instructions to make standard deviation. So do the bits that you can do easily. So for here, you know that the N is 5, because you've got 5 sets of data, so that's an easy one to do. That's a bit big, let's make that smaller. It's a bit small, let's make that bigger. That'll do. So 5 minus 1, which is the equivalent of 4. Nice. You've just plugged in the thing you know. Now, you want to do the things in the bracket first. So I'm going to run through you the 100 and hopefully you'll be able to do it for the 200. The thing in the bracket is this bit here. Which is your data value minus the mean. So in here it would be 9 minus 10, which would be minus 1. let's actually use that, that'll be better. So minus 1 will be your first one, then it'll be 11 minus 10, which should be 1, then it'll be 11 minus, no, sorry, 9 minus 11. No, oh, I got confused. This is fever brain. Let's try again. First of all, it will be 9, because it's your first bit of data. Then you minus the mean, or the average. So it will be 9 minus 10, which equals minus 1. The next one is 11 minus 10, which is 1. Then 9 minus 10, which is minus 1. Then 11 minus 10, which is 1. Wait, I've missed one. Oh, for goodness sake. Oh, 10 minus 10, which is 0. I'm struggling. I'm not gonna lie. Okay, nice. You've done the bracket bit. Now, what you want to do is the bit connected to the bracket bit, to the little 2. You want to square it. You want to square all these values. So you put it into your calculator. If anyone doesn't know how to do this, please, someone who does, help the class out. So minus 1 squared is 1, is a minus, it's essentially minus 1 times minus 1. And a minus times a minus makes a plus. So the first one's 1, then it's 1 times 1, which is 1, 0 times 0, which is 0, minus 1 times minus 1 is 1, then 1 times 1 is 1. Okay, nice. So you have now got all the values for this bit. Nice. Now, this sum bit, the pointer E, means you add together all the values you calculated for this bit here, which are here. You just calculated. So it'll be 1 plus 1 plus 0 plus 1 plus 1, which is 4. Nice. You've just done this bit. So you now pop in a 4. You want to do the easy bit first, which is this bit over here. 4 divided by 4 becomes 1, and then you've got one final bit to do, which is the square root of 1. You should be able to find this on your calculator. It might look like this. It might have like a little 2 up here. So the square root of 1, and your S value will be hopefully 1. Now this S value, 1, the standard deviation that you've just calculated, means that these values up here, so the 9, 11, 10, 9, 1, 11, on average deviate or change from the actual average by 1. I'd like you to have a go for the 200. So do the bits you know first, so the n minus 1, that's an easy bit. The number of values you have are 5. Then you'll want to do the bit in between the brackets, which is these values minus your average or your mean. You then want to square these values that you get. So you're doing this 2 bit now, which is the same as multiplying it by itself. After you've got all those values, you want to add these values you've just calculated all together, and then hopefully you'll have something that you can plug into here. So you should have something divided by 4. You then do that calculation. So for example, if it ended up being 10, it's probably not, I'm just making up a value. You do 10 divided by 4, which is 2.5. And then you'd want to do the square root of that number. And you've got your standard deviation. This is a class effort now from this point. So please discuss, please help each other out. I do not know who's struggling because I cannot see. I cannot see you guys. So you're going to have to help teach each other. Just do it for the 200. To repeat one more time, do the n minus 1 first, because that's the easiest bit. You've got 5 of these, 5 little data sets. So you put 5 in the n. 5 minus 1 is 4. Nice. You can write this equation again with a 4 at the bottom. You then want to do the bit within the bracket. So for example here, you do x, which is your value here, 15, minus x with a hat, which is your average or your mean, which is 16.4. You end up getting minus 1.4. Wonderful. Do that for all your values. You'll get a list. You then want to do the little 2 bit, the squared bit. So all these values you just calculated, I'd like you to times it by itself, or square it if you've got the option on your calculator. They should all be positive values because a minus number times a minus number is a positive number. Once you've got all of those, I'd like you to add them up because that's what this little sum means. And you should have a figure that replaces this bit. You then divide it by your 4 to get a straight number. And the final little bit you want to do is square root that number. Actually, I'm going to work it out myself and let you know the number that I come up with. Whoops. Just to make sure you're on the right track, this first one, we've done 15 minus 16.4, so you would have got minus 1.4. You square it, so times it by itself, and you should get 1.96. You can do the rest. I'm going glad I managed to get to the volume there in time. That was not a healthy sound. So, hopefully you're on track. I'm using a calculator, by the way, not looking at memes. A bit awfully rude. Be funny if someone in the class actually was using their phone to look at memes at that particular moment and feels like I'm calling them out. Now that would be wonderful. So for this top value here, with all the data points minus the average and the square that number, and summed all together, add them all up, I got 17.2. I might be wrong with that. Just double check with everyone else. I got 17.2. Give you a little bit longer. So if you do 17.2, you divide by 4, you'll get this bit here, which should be about 4.3. If you do the square root of that, you'll get the standard deviation. Oh dear, I feel a sneeze coming along. Oh. And now I've got that edge of a sneeze sensation. Oh dear. Oh dear. That is irritating. Ah. Nice. Okay, so I got the standard deviation of the second column to be about 2.1 or 2.07364, but make it an easier number. So 2.1. So it's a similar style to here. So if you've got your standard deviation of this first one being 1 and the second one being 2.1, this means that these values on average deviate or change from the average or the mean by 2.1, whereas these are only by 1. So when you plot a little graph, let's see if I can do this. If you plot a little graph, this first one, let's say it's average of 10, the second one is average of 16.4. This first one is more reliable than this second one because it deviates less. This final one, 400, the 400 one, let's say it's probably up here, will deviate way more, so it's much less reliable result. You can plot these on Excel, add a little error bars, and they make it look like this. It shows you the little range that the values could be between. The smaller the little error bar, the more reliable your data. Nice. We will touch upon this again in the next few weeks because I want to keep reintroducing it to you. If you can kind of get your head around it today, you've done a really good job. You did a really good job because this is, I think, the hardest part of your year is the little mathematical notations. So be proud of yourselves if you kind of understood it. Be very proud if you do understood it, did understand it, and were able to do it by yourself. Nice. Nice. Okay. Now, I don't know how long I've been rambling for. I really don't. So I'm going to stop the recording now and figure out how long this has been going for, because I think your first lesson with me is about an hour and a half. I don't think I've been talking for an hour and a half, but I also understand that these lessons are less entertaining than when I'm dancing around the room. So if it's okay with whoever's covering, I would like to let you go slightly earlier today, but that doesn't mean now. Not necessarily, because I don't know how long I've been talking for. But if I could let you out 15 minutes earlier, upon the good grace of the beautiful and smart and talented covering lecturer, then I will. But it's up to them. So I'm going to quit this recording, and if we're nowhere near the hour and a half mark, I would like the second video to be played, and I'll talk about the next parts. Nice. I might see you in half an hour. I might see you in 10 to 15 seconds, or even a few minutes, depending on whether the computer likes to play along. Nice.